You click the box that says you are not a robot, and then it asks you to prove it. Select all the squares with traffic lights. You pick the obvious ones, and it fades in three more, slightly blurred, half behind the pole. You pick those two, it thinks for a second, then asks about crosswalks. You have now spent 30 seconds convincing a website you are a human being. And the strangest part is this: the machine on the other side already had a very good guess about you before you clicked a single square. The puzzle was almost a formality. So the real question is not whether you can solve a CAPTCHA. The question is how a test that was supposed to be easy for people and hard for machines slowly became the opposite, and what replaced it when it did. A test built on a gap. The original idea was clean and almost beautiful. Find a task that is trivial for a human and genuinely hard for a computer. Put it between the user and the thing they want, and let only the humans through. Read these wavy letters. That gap, the space between what people find easy and what machines find easy, was the whole product. For a while it held. A person could glance at distorted text and just read it, while the software of the day choked on the curves and the noise. But a gap like that is not a wall. It is a finish line that the machines are walking toward, slowly, every single year. And the entire history of the CAPTCHA is the story of that gap closing. The golden age of wavy text. Distorted text was the first great era, and you remember it. Stretched letters, strike-through lines, a wash of visual static behind them. The design assumption was that reading messy text required something uniquely human. For a few years that was true. But reading distorted characters is exactly the kind of problem that machine vision is built to crush. Researchers trained models on the noise, then on the warping, then on the specific styles each provider used. The harder the text got, the more it punished real people with bad eyesight and bad screens, while the software kept improving. Eventually, the machines read the hardest versions more reliably than tired humans did. The gap had not just closed, it had quietly flipped. There is a famous detail from those years that tells the whole story. The wavy text people typed in was, for a long time, doing a second job. Some of those words came from old books and newspapers that machines had failed to read during digitization. One word in the box was the test, the word the system already knew. The other was a real, unknown word from a scanned page, and your answer helped transcribe it. Millions of people every day were quietly finishing a job the computers could not. That was clever and a little unsettling, and it was an early hint of a pattern that would repeat. The puzzle was never only a puzzle. It was also work, and it was also data. When the puzzle reads better than you, think about what that flip means. The test was supposed to be easy for humans and hard for machines. By the end of the text era, the squinting, the retries, the is that an O or a zero, all of that landed on the humans. The automated solvers, meanwhile, sailed through. When your security check is harder for your real users than for the thing it was meant to stop, it has stopped being a gate. It has become a tax you charge honest people for the privilege of proving something the attacker can fake more easily than you can verify. That realization is what pushed the whole field toward its next idea. Select all the traffic lights. So the puzzle moved from text to images. Identify the storefronts. Click every square with a bicycle. On the surface, this looked like a smarter gap, because understanding the content of a photo felt more human than reading letters. But there was a second thing happening underneath, and it is the part most people never noticed. The images were not random. Many of them were real photographs that needed labeling. Street scenes, house numbers, objects a company wanted a machine to learn to recognize. Every time millions of people clicked the crosswalks, they were teaching a model what a crosswalk looks like. The puzzle that trained its own replacement. Sit with the irony of that for a moment. The test that was supposed to keep machines out was, at the same time, a vast unpaid workforce, teaching machines how to see. Your annoyance was the labeling step in someone else's training pipeline. And as those models got better, fed in part by the very puzzles meant to stop them, the same vision systems that learned to read street signs could increasingly solve the image grids too. The defenders had built a tool that improved the thing it was defending against. Once again the gap narrowed, and once again the people who broke these systems for a living adapted faster than the puzzle could. The puzzle gets harder, the people get cheaper, Here is the part that breaks the whole premise. You do not actually need a clever machine to solve a CAPTCHA. You can just pay a person. There are services that route a hard puzzle to a real human somewhere in the world, who solves it for a fraction of a cent and sends back the answer in seconds. To the website, that answer looks perfectly human, because it was. And this is the quiet truth the puzzle era could never escape. Any test a human can solve, a human can be paid to solve, at scale, for almost nothing. Making the puzzle harder does not stop that. It just makes the honest user suffer more while the operator pays a slightly higher rate per solve. The economics of that are brutal in a way the early designers never planned for. A single solve might cost a tiny fraction of a cent, sent to whoever is awake and willing to click squares for hours. The puzzle, which felt like a wall to you, is just a line item to the operator, priced in thousands of a dollar and absorbed without a second thought. And because the work is so cheap and so easy to describe, it scales almost without limit. You cannot win a price war against human attention itself. So a defender who leans entirely on a puzzle is in effect charging the attacker a few cents and charging the honest user a few seconds of their life over and over forever. The puzzle was supposed to be a test of identity. It had quietly turned into a toll booth that only the wrong people could afford to ignore. Why harder puzzles punish the wrong people? So the defenders were trapped in a losing trade. Crank the difficulty up, and machine vision catches up within a year or two, while paid human solvers handle whatever is left. Crank it down, and it filters nothing. Every notch of added difficulty fell hardest on the people the test was never meant to catch, the ones with slow connections, older eyes, screen readers, or simply a bad day. The attacker has a budget and a tolerance for friction. The real user has neither. A security mechanism that hurts your customers more than your adversaries is not a security mechanism. It is a leak with a logo on it. The puzzle, as a category, had run out of room. The test goes invisible. This is where the real shift happens, and most people never see it because the entire point is that you do not. The newer systems mostly stopped asking you to solve anything. Instead, the moment you arrive, they start watching how the mouse drifts toward the button. The tiny pauses, the little overshoot and correction, the way a real hand is never perfectly steady, the rhythm of your scrolling and your typing. For most visitors, the verdict is reached before a puzzle is ever offered, and the puzzle simply never appears. The check did not get easier. It went quiet, and it moved behind the curtain. The score that decides for you. Underneath the calm checkbox sits a number, a risk score. The system gathers everything it can see, the way you move, the reputation of your address, the age and history of the browser, whether your story is internally consistent, and it asks one soft question: how human does this whole session look? If the score is comfortable, you pass invisibly, no traffic lights at all. If it is borderline, you get the puzzle, not because the puzzle proves much, but because it adds friction and buys time. If the score is bad enough, you can solve every crosswalk perfectly and still be quietly turned away. The puzzle stopped being the judge. It became a tap on the shoulder for the cases the score was unsure about. Reputation arrives before you do. A lot of that judgment is decided before you do anything at all. Your network address carries a history. The browser may carry a fingerprint seen on other sites, attached to other behavior, good or bad. A fresh, clean session with no past is itself a kind of signal, because most real people show up trailing years of ordinary, boring activity. The defenders are not only watching this one visit. They are checking it against a memory that stretches across many sites and a long stretch of time. You walk in already wearing a reputation, and the door reads it before you say a word, when a perfect answer is not enough. This is the idea that confuses people most. How can you solve the puzzle correctly and still fail? Because by the time the modern system shows you a puzzle, the puzzle is not really the test anymore. It is one more data point on top of a verdict that was mostly formed already. The human solver you paid can return a flawless answer, and the session around that answer still moves like a script, still comes from an address with a bad history, still shares a fingerprint with 2,000 other accounts doing the same thing in the same minute. A right answer inside a session that looks wrong does not rescue it. The test moved up a level, away from the box and onto the whole shape of the visit. From puzzle to judgment, step back and you can see the entire arc in one line. Every time the test got harder, the machines caught up. Wavy text failed to vision models. Image grids trained the very systems meant to beat them, then failed too. Paid humans solved whatever was left for almost nothing. So the defenders stopped trying to find one perfect puzzle that only humans could pass, because no such puzzle exists for long. They stopped asking, can this visitor solve a riddle? And started asking, does this entire session behave like a real person living a real life? The CAPTCHA did not get smarter. It stopped being a puzzle and became a judgment, rendered quietly in the time it takes a page to load. Why the defenders keep the edge? And this is the asymmetry that keeps deciding the contest. The operator trying to look human has to get everything right at once. The movement, the address, the history, the consistency of the whole story, and keep getting it right as the checks shift underneath them. The defender only has to notice one thing that does not fit. Better still, the defender watches an ocean of real people every single day, for free. Which means they always have a fresh, accurate picture of what normal actually looks like. A puzzle could be studied and beaten. A constantly updated sense of human normal is a far harder thing to imitate. Because the moment you copy today's version of normal, normal has already moved. What the arms race really teaches. So here is the part worth keeping. The CAPTCHA was never really about traffic lights or wavy letters. It was about a gap between human and machine that the machines kept closing until the defenders gave up on the gap and started judging the whole person instead. And the same scoring that frustrates a bot is what protects you. The system that decides a login looks wrong is the reason a stranger with your stolen password in a faraway city on a device that has never been yours gets stopped at the door. You almost never see this layer. But it is now sitting under nearly everything you do online, quietly deciding, before you have solved anything, whether it believes you are real. If this is the kind of thing you find yourself thinking about, the invisible machinery under the ordinary internet, then this channel is your sort of place. No product, no pitch, just the systems taken apart and explained by someone who has spent a long time on the inside of them. Subscribe and follow the rabbit hole. Simoskem kentom nice diuming tinin night nistenver decides, in a fraction of a second, whether the person spending your money is really you. How your bank knows it is you. The dozens of quiet signals it reads before it ever asks for a code. And how organized fraud rings study those exact signals and build entire operations to beat them. It is the same arms race, with far more money on the table.